From your smartphone to the cloud services you use every day, software is the engine that powers our modern world. It's everywhere, running silently in the background, making our lives easier and more connected. But have you ever stopped to think about what it takes to build truly reliable software? It's not just about writing lines of code. In fact, some of the biggest and most frustrating software bugs don't show up in a developer's neatly controlled environment. They emerge in the wild after the software has been released to millions of users. Today, we're diving deep into a topic that every software engineer and tech enthusiast should understand: why most software bugs happen in production, not during development. It is a common misconception that software bugs are simply the result of a developer making a careless mistake or writing bad code. While coding errors are certainly a factor, they represent just the tip of the iceberg. The real story is far more complex and fascinating. In many professional software companies, a familiar and often stressful pattern emerges. The development team builds a new feature. It passes all the internal tests with flying colors. The quality assurance team gives it the green light. Everything seems perfect. The team celebrates a successful launch. But then, the support tickets start rolling in. Real users are experiencing crashes, errors, and unexpected behavior. The system that worked flawlessly in a controlled setting is now failing in the real world. Why does this happen so often? It's because the production environment is a completely different beast than the development or testing environments. Let's break down the key reasons behind this phenomenon. One of the most significant culprits is what we call environment drift, or simple environment differences. Think of it this way: a development environment is like a pristine, quiet laboratory. A production environment, on the other hand, is like a chaotic, bustling city street. No matter how hard a company tries to replicate its production setup for testing, it's virtually impossible to make them identical. There are subtle but critical differences in operating system patch levels. Library versions, network configurations, hardware specifications, and security settings. A feature might rely on a specific version of a software library that is present in the test environment, but has been updated or configured differently in production. A network firewall in production might block a port that was open during testing, causing a crucial connection to fail. These seemingly minor inconsistencies can trigger latent bugs that were completely invisible during the development cycle. It's like testing a car on a smooth, empty racetrack and then being surprised when it has trouble on a bumpy, congested city road with different traffic laws. Next, let's talk about the human element, real user behavior. When developers and testers use a system, they tend to follow happy paths. They know how the software is supposed to work, so they click the right buttons in the right order. They input data in the expected format. But real users? They are wonderfully unpredictable. They will click buttons repeatedly and rapidly. They will have multiple browser tabs open to the same application, creating confusing session states. They will use the back button in ways the developers never anticipated. They will enter emojis into a text field that was only designed for letters. They will leave a page idle for an hour and then try to submit a form. This unpredictable, chaotic interaction is something that automated tests can rarely simulate effectively. These edge cases, born from the creativity and impatience of real people, are a primary source of production bugs. The system is designed for a perfect user, but it has to survive in a world of imperfect, real users. Then there's the immense challenge of scale and traffic volume. A test environment might be stress tested with a few hundred or maybe a few thousand simulated users. A production environment for a popular service could be handling millions of concurrent users. This massive increase in load can expose a whole new class of problems that are impossible to find at a smaller scale. For example, race conditions can occur where two or more processes try to access the same shared resource at the exact same time, leading to data corruption. At low traffic, the chances of this happening are minuscule. At high traffic, it becomes almost inevitable. High load also puts immense pressure on memory and CPU. A small memory leak that is undetectable during a 10-minute test session can grow over hours or days under constant production load, eventually crashing the entire server. Performance bottlenecks that were theoretical during testing become very real, slowing the application to a crawl and causing timeouts and failures for users. Scale changes everything. Another major source of production pain is integration with third-party services. Modern software is rarely a monolith built entirely in-house. It's more like a complex ecosystem of interconnected services. Your application might rely on an external payment gateway, a social media login API, a cloud database, or a content delivery network. You have no direct control over these external systems. What happens if one of these third-party services suddenly becomes slow or unavailable? Your application might hang, waiting for a response that never comes. What if that service deploys an update that subtly changes its API response format without notice? The part of your code that relies on that specific format will instantly break. These dependencies create a fragile chain. A failure in one link can cause a cascade of failures throughout your own system. Testing these integrations is notoriously difficult because you can't control the external environment. You might test against a sandbox version of the API, but it's never a perfect replica of its live production counterpart. Configuration mistakes are another silent killer in production environments. Modern cloud-native systems are incredibly powerful, but also incredibly complex to configure. We're talking about thousands of settings across dozens of services, from database connection pools and cache expiration times to security permissions and auto-scaling rules. A single misplaced value can have disastrous consequences. For instance, a developer might accidentally set a timeout value to 50 milliseconds instead of 5,000 milliseconds, causing legitimate, long-running operations to fail constantly. Or a misconfigured security group rule could block the application server from talking to its database. These errors are often not code-related at all. They are human errors made during the deployment or maintenance process, often under pressure. Because these configurations are specific to the production environment, they are completely missed by pre-production testing. A single line in a configuration file can be the difference between a healthy system and a complete outage. Finally, a critical and often underestimated factor is the lack of sufficient monitoring and logging. Even if a bug occurs in production, how do you know it's happening? Without proper visibility into the system's health, bugs can exist for hours, days, or even weeks before anyone notices. By the time customers start complaining, the damage may already be done. Effective production systems need comprehensive monitoring that tracks key metrics like error rates, latency, CPU usage, and memory consumption. They need robust alerting that notifies engineers the moment these metrics cross a dangerous threshold. And they need detailed, structured logging that provides the clues necessary to diagnose the problem. When a bug does occur, good logs are like a black box flight recorder for your software. They tell you exactly what was happening in the system at the moment of failure. Without this visibility, engineers are flying blind, trying to debug a problem in a complex system with no information. Small issues fester and grow into major incidents simply because no one was watching. So, as you can see, testing is absolutely essential, but it is not a silver bullet. It can't catch everything. The idea that you can test your way to a perfectly bug-free system before launch is a myth. The most resilient and reliable software is built by teams who understand that production is the ultimate testing ground. They embrace this reality. They don't just focus on pre-production testing. They invest heavily in production observability with great monitoring, logging, and alerting. They build systems that are designed to be resilient to failure with features like automatic retries, circuit breakers, and graceful degradation. They have fast feedback loops and streamlined processes that allow them to detect, diagnose, and fix production issues in minutes, not days. Most production bugs are not just simple coding errors. They are complex, system-level problems that arise from the interaction between code, environment, scale, third-party dependencies, and human behavior. Understanding this fundamental truth is the first step toward building software that can truly withstand the chaos and complexity of the real world. It transforms the engineering mindset from preventing all failures to building for resilience and rapid recovery. I hope this deep dive has given you a new perspective on the challenges of building and maintaining modern software. It's a field full of complex and interesting problems. If you found this video insightful or useful, please hit that like button. It really helps the channel out. And I'd love to hear your own stories or thoughts on this topic, so drop a comment down below. For more content like this, don't forget to subscribe and turn on notifications. Thanks so much for watching, and I'll see you in the next one.